Obviously, what they didn't do is they didn't build a scale model of this, put it in a wind tunnel. Tacoma Narrows is an incredibly windy place, yes? We're talking like near here, near Seattle, right? Yeah? Well, they didn't do a wind tunnel test of this, and so the bridge just started, first it did this thing where it would hump up and down like this in the middle, then it started doing this twisty thing, and they couldn't stop it. And everybody says, gee, I didn't know concrete could do that. What are suspension bridges made of? The deck is concrete, but yeah, they're made of steel. There's steel beams holding it up. The strength of it is steel, right? And so the steel is what's bending here. Steel is incredibly flexible. Isn't that amazing? I don't know what that is. Right? That's one of the beams. There we go. And then, of course, yeah, there it goes. It collapsed. Let's see if we can get the collapse. The only fatality was there was a dog in this car. The guy went out to rescue the dog. The dog attacked him. He backed off, and then shortly thereafter, the thing collapsed. Like, oh, the camera started rolling a little bit late, right? This is real film cameras, right? All right.
Now we're going to make the school explode?
Well, I think so. I don't know. What?
We got a 52.
We got out 52, is that right?
Yeah.
Oh, this is good news. All right. So let's at least annoy Youngberg, if not make the school explode. All right. If you would grab that extension cord there.
With this one?
Yeah. I just need to get plugged in over there.
Plugged in, yeah.
Here we go. Here, come on out here. Leave your stuff. Just come out here. We'll have time.
Plug it in.
Yeah, go ahead. So I love this door post, right? That's something that could resonate, isn't it? Keep coming. There's more of you than that. Some people can go over here. Keep going, keep going. Is that everybody? C'est tous les gens? All right, are we ready? So this post, whenever I walk by this post, I love this post. It resonates like that. So let's just see if we can find that frequency here. Too fast, right? That's about right, isn't it? That's pretty good, isn't it? Let's see how long it takes Youngberg to get out of here. What's he doing? He's probably listening to like music. What's he doing? Back up! Ah! All right, little applause for that. All right.
I thought the school was going going to explode.
Well, I decided not to make the school explode.
But he had one of these on every door. Does the school have a resonance?
Well, think of one of those big concrete pillars, right?
Yeah.
Those might have a resonant frequency. Would one of you gentlemen grab that cord? I know. If I left this in the hall, for sure we'd have to evacuate the school.
What?
Excuse me.
Where you want the cords? Ow.
If you could coil that up and then just set it over there, that'd be great. Okay, and then the final thing, and I'll leave you with this notion. Okay, there is something called nuclear magnetic resonance. Okay, and when you take organic chemistry, you will do analysis with nuclear magnetic resonance. And the notion is this: you just have a test tube, and you've got a very powerful magnet. It's a very strong magnet. You stick the test tube down in there, and then what you do is you hit it with basically all different frequencies of radio waves. And you've got a sensor, a little thing that detects, gentlemen, nothing's more important than nuclear magnetic resonance. Okay? You've got a little sensor that detects resonance in the chemical compounds. Now, the cool thing is that if you've got like a C double bond C OH or something like that, some organic thing like that, that's got a particular frequency it resonates at. So when you get your output like this is the intensity, here's the frequency, you get these little spikes. Now, you probably won't be able to read it, but the graduate students that are helping you in the lab will go, oh, that's alcohol, you got ethanol in there, right? Or you've got acetone, or you've got, right? So there's certain particular things, and it's like the notes of a piano, right? There are particular resonances that are associated with particular things, and you can identify the compound by the particular frequencies it resonates at. So the radio frequency just tries all the frequencies, right? And then it can tell you that, right? Now, when you go to the hospital and they do imagery on you and they stick you inside a magnet and they do an MRI, understand that there's no magnetic resonance. There's only nuclear magnetic resonance. They've just discovered that people don't love to be stuffed inside a giant magnet with it says nuclear on the side. So they've dropped the nuclear, but it is all nuclear magnetic resonance. It's the nucleus of the atoms that has a magnetic moment, and that nucleus resonates. Isn't that a wild thing? So you can actually identify compounds. So they can actually, in theory, they can actually identify inside a suitcase with MRI not only what the different things are, but what the different substances are. Is there plastic explosive in there, or is that deodorant or something like that? We're not there yet, but we're going to get there sometime soon, right? So that, I don't know, that's a cool thing. Is that a cool thing? Yeah, there we have it.